Hi, I'm Matt Nachove, Executive Editor of Plastics Technology Magazine, and I'm here with Wayne Daniel, Business Development Director for Canon Virginia. So, Wayne, I understand that this involves a family mold with, I think, as many as 4 cavities. Could you describe the parts and tell us how this molding project came about?
Sure, absolutely. So for this is actually an application for like a plumbing type application. So we made a series of nylon pipes. We made a straight section of pipes, roughly 6 inches long. And then we also made a S-shaped pipe. And that's where the tricky part came in, was being able to mold this part with that severe undercut that's created by the S shape and get that part out of the mold. It kind of started because this was a development project for a customer. And actually we collaborated with Toyo Machinery. Canon and Toyo Machinery collaborated with this to try to mold this part that's typically difficult to mold by normal injection molding because of the part shape. So the idea was, if we utilized Canon's technology with shuttle mold, we could reduce the part cost and combine some things together, such as in-mold assembly, overmolding, and assembly. So that's kind of how the project developed as a proof of concept. And we did that and showcased that at K-Show, the last K-Show in Germany.
Mm-hmm. Okay, so could you describe how this technology works in terms of how are you able to mold? I think it was 4 halves of 2 parts and do overmolding and all of that. How does the shuttle mold concept work to make this
So
happen?
absolutely. So instead of molding the part as is in one cycle, in one shot, with a hollow center, basically we molded each of the parts, the straight section and the S-shaped section, in halves. So we molded a half, a top and a bottom, if you will, of the straight, and top and the bottom of the S-shaped pipe. That's where the 1x4 family tool came in. From there, so we did that in one mold. Then we took those out and we put those into a second mold automatically with the robot, and put one side on the A half, one side on the B half. And when the mold closed, we did the end mold assembly and snapped those pieces together. Then in order to seal that, because it is a pipe, it does have fluid going through it, or it will have fluid going through it in its use. Basically, we then overmolded that assembly that we just made with the base nylon resin to create a strong part, and then also a part that's sealed. So the shuttle mold system is a system that allows you to run 2 molds in one machine at the same time. We have a mold A and mold B, and those molds are shuttled in and out of the machine every cycle. So essentially every cycle there is a changeover between mold A and mold B.
And you're continuing to cool the mold when it's outside the press?
Correct, and that's the other big advantage. So being this winds up being a thick part by the time we overmold it, with typical traditional molding, that thick of a part would have, very long cycle times in order to get the heat out and cool that. With the Canon shuttle mold system, we do our cooling on the outside of the machine. So the goal with that is to always keep the machine working, because typically about 2/3 of the overall cycle time is cooling time. So while your part is cooling in the mold, basically nothing is happening. The machine's not working. So the shuttle mold system will allow you to do that cooling on the outside and then take advantage of keeping the machine working, which essentially will increase your productivity, because you're always filling, packing, another part while you're also cooling part A, for example.
What was the biggest technical challenge in accomplishing all this?
So the biggest challenge was trying to figure out how to overcome that difficult to mold shape of the S-shaped pipe while keeping the tooling relatively simple, as opposed to having very complex core outs and slides and everything to create that hollow section. And then also trying to keep the machine size relatively small. So we were able to do that by molding the parts in halves and then doing the end mold assembly and overmolding. Otherwise, we would have had a very complicated mold, which one is expensive, two, it's difficult to maintain, and three, there's risk of something happening during, say, production when you have all that complexity. So that was probably the biggest thing. And then on the machine, if we'd have done this with traditional transfer molding or something like that, insert molding, we would have either had to have multiple machines to do that, which would require additional steps, or have a very large machine to do the transfer molding and so forth. So we were able to do this in the end with two very simple standard injection molds, if you will, with not a lot of complexity. And then also the machine size, we kept that to around 230 tons. So from a machine side point of view, in a production environment, obviously your molding rate on a small machine is less than on a large machine. So part cost, would be decreased.
Indeed, indeed. Now, this shuttle mold technology, is this relatively new? Do you have a lot of experience in using it?
Internally, we developed this to use for Canon products, actually. The development started, and we've been using this since 2014 internally at our facilities. We decided to showcase this technology at NPE, actually, in 2018, just as a showcase of what Canon's molding technology, and not necessarily commercialize it. However, we received so much interest in that.
Okay,
so we started to collaborate with other molding machine makers, and starting from 2019, we commercialized this.
Great. Well, thank you very much. I think this is an interesting project and an interesting technology.
Thank you, Matt.